Hello and once again welcome to Knowledge. In this lecture, we are going to discuss about logarithmic differentiation. This is a chapter that you will encounter in class 12. Okay, so this is a video for class 12 students and also for them who are appearing for JEE mains. Now, what is logarithmic differentiation when we apply it? Okay. Suppose you are encountering something like this, y equal to fx to the power gx, y equal to fx to the power gx. This is a type of function. For example, x to the power x, log x to the power sin x, this type of things. Okay, this type of things. Now, how to differentiate them? Now, some of you may say, this is simple. I'll say how? Your answer will be like this. So dy dx is nothing but gx into fx to the power gx minus 1, and here you are committing a blunder. Okay, this is a blunder. You should not do this. This is a wrong answer. Why? Understand? What was the formula for this? If y equal to x to the power n, then you used the formula for the differentiation. This was the formula. Okay. Now, what is the basic difference between these two? Look, in this thing, in this example, the n, which is in the exponent, this was a real number. This was a real number. But here, gx, this is a function of x. This is the function fn dot. Okay, this is function. Gx is nothing but function of x. So there is a basic difference. In this, x to the power constant, x to the power n, x to the power 5, x to the power minus half. Okay, but here gx is a function of x. This is not a constant. So we do not use this formula. So the previous one that you have suggested me earlier, don't use it. So if not that, then what? Here comes the log. Log rescues us in this kind of situation. Perhaps you know that if there is a quantity a to the power b, if we apply log, then what happens? This b comes to here. Okay, this b comes in the front as a multiplication. Pardon me. So we will be applying this technique here. So apply log on both sides. Apply log on both sides. Just beg your pardon. Thank you for your patience. Apply log on both sides. So log y is equal to log fx to the power gx. Why are we applying log here? So that gx comes first in the multiplication, and then we'll be applying u into v rule. We'll be applying u into v rule for differentiation. Got it? So now apply differentiation on both sides. So ddx of log y equal to ddx of gx into log of fx. Fine. Now for left hand side, we'll be applying the implicit differentiation. We'll be applying for implicit differentiation. ddy of log y into dy dx equal to first u into v. This is the u first function, this is the v second function. Fine. So derivative of u g dash x, while the v is constant, v is remaining fixed, plus gx is fixed into differentiation of log fx. Now log fx, it is a function of a function. That means we do not have direct formula for this. We have to apply for chain rule. So chain rule suggests that first we have to differentiate log. That means 1 upon fx into the derivative of f, that is f dash x. Okay. So what is d dy of log y? We are differentiating log y with respect to y. So this is nothing but 1 by y into dy dx as it is equal to g dash x into log fx plus gx into f dash x by fx. This is the penultimate step. Fine. Now, so dy dx equal to this y will go to this side, and y means nothing but fx to the power gx. So fx to the power gx into g dash x into log of fx plus gx into f dash x by fx. This is the answer. This is the answer. Fine. So basically this is a generic answer. This is a generic answer. That means if we encounter y equal to fx to the power gx, then following this procedure we will be reaching this step. This will be the answer. But how to apply this? We will be seeing in an example. Fine. So dy dx is this. If this is clear, then we move on to a problem. So let's erase this. I hope. Two of these things are disturbing me continuously. So suppose we are taking this one, y equal to x to the power x. Find dy dx. This is of the form fx to the power gx, where fx is x and gx is also x. Fine. Let's solve. So first take log y equal to x into log x. This x will come to the front. Okay. This x will come to the front. Now differentiate with respect to x. This implies d dx of log y equal to d dx of x into log x. So what is this? Implicit differentiation, d dy of log y into dy dx equal to u into v. This is u, this is v. Derivative of u, derivative of x is 1 into log x plus x is fixed. What is differentiation of log x? 1 by x. Okay, that's how we do it. So this will get cancelled. So 1 by y. What is derivative of log y with respect to y? That is 1 by y. So 1 by y dy dx equal to log x plus 1. So dy upon dx is nothing but y into this quantity. What is y? Y was x to the power x. So x to the power x into log x plus 1. This was the first problem. Very simple. If you practice this is very simple. Got it? Now come to the second problem. Y equal to log x to the power sin x. So again fx to the power gx term. So dy dx, first take log y equal to sin x into log of log x. Okay, we are taking log on both sides, so sin x comes first, sin x into log of log x. Now both side differentiation. Now notice that in each and every case we are differentiating log y with x. Okay, we are differentiating log y with x, and the result is always 1 by y into dy dx after differentiation. Okay, now for this one, this is the u quantity, this is the v quantity. So first, for sin x, the derivative is cos x into the log x is fixed plus sin x into. Now, what is the differentiation of log? This is composition of function, function of function. So differentiation of log is 1 by log x into, what is the differentiation of log x? The inside log, that is 1 by x. Fine. Now dy dx is nothing but y into this quantity. What is y? Y means log x to the power sin x. Log x to the power sin x into cos x into log of log x plus sin x by x into log x. Okay, this is how we solve the logarithmic differentiation. Fine. This is one type of application of logarithmic differentiation. There are also some other applications, like when you will be encountering this type of thing, like y equal to x minus 1 by x minus 2 whole cube plus x minus 3 whole square by x minus 1 whole to the power 4. You have to differentiate this. If this is the same, then also you have to apply log differently. Okay, log on each of the terms. There are other methods also, but log will do it. Log will help you do it easily. Fine. So I hope logarithmic differentiation is clear to you. Very simple concept, but you have to practice it. The more you practice, the more you will be able to do the sums in your exam. So I hope the video helps you. If you like the video, then please subscribe our channel and stay tuned for our next videos. Thank you.